Hi, in this example, we're going to be given a series of attributes of a rational function, and we're going to build the actual function. So you'll notice there's three pieces of information that they give us. The first piece is information regarding the vertical asymptotes. The second one is regarding the x-intercepts. And the third piece of information is the y-intercept. So, there's a couple of things we need to recall. Recall that first, where a rational function is undefined is where the denominator is 0. And where this is undefined, it means there's vertical asymptotes. Okay. The second piece of information is where a rational function is 0 is when the numerator is 0. Okay, so here in 1i, they tell us that vertical asymptotes are at x equal -4 and x equal 1. This means that if vertical asymptotes are where the denominator is 0, meaning where the rational function is undefined, then I can create factors for these in which would be in the denominator, because it would make the denominator 0, creating vertical asymptotes. So the vertical asymptotes in the denominator of the function would be the factors x plus 4 and x plus 1. Because of the negative, if we recall, it would be x minus -4, which turns to plus, and that's why we get the plus. Okay, second piece of information that we get is the x-intercepts. So where a rational function is 0 is where the numerator is 0. Well, where the numerator is 0, these are the x-intercepts. Meaning that these would be, if I rewrote these at intercepts as factors, these factors would be in the numerator. So again, it's x minus a -2, which is x plus 2, and then x equals 6, meaning it'll be x minus 6. So, and let's write my rational function. Let's begin. So my rational function, let's just call it r of x, is equal to some numerator over the denominator. Okay, this numerator is where x-intercepts lie, okay, or where it's 0, okay, and the denominator is where you have vertical asymptotes. And that's where the rational function is undefined. So if I rewrite this rational function in terms of my factors that I wrote up here, the numerator would be x plus 2, x minus 6, and the denominator would be the vertical asymptotes, x plus 4 over x plus 1. So the numerator is the x-intercepts, and the denominator is the vertical asymptotes. Okay, but then you still have some constant coefficient in the front, k. So even though we found the rational function, there is some sort of vertical stretch or compression that may occur. It may be that k is 1, we don't know. But this is where the third piece of information up here comes in. If we know the y-intercept is at 8, this means that this is the ordered pair 0, 8. Why not plug and chug 0, 8 into r of x and solve for k? So this way we get r of 0, which is equal to k, times 0 plus 2 times 0 minus 6 all over 0 plus 4 times 0 plus 1. So r of 0, the y value is 8, and this is equal to k times 2 times negative 6 over 4 times 1. So this is negative 12 over 4. So 8 is equal to negative 3k, and now k is equal to negative 8/3. So this actually has a vertical compression by a negative factor of 8/3. Writing this all together, we get r of x is equal to negative 8/3 times x plus 2, x minus 6, all over x plus 4 and x plus 1. And I don't think you have to, multiply that out. I think it looks fine the way it is. As we look over here to the left, we could see that this is, in fact, the answer.